Alright, so let's talk about chemical bonding, or how and why atoms stick together. So, a chemical bond is an attraction that holds two or more atoms together. And unlike the device that's holding former President Bush's fingers here, we can't see chemical bonds. They are invisible. But, just like gravity, we definitely know it's still there. Now, atoms are attracted to each other because of that electrostatic attraction between positive and negative charges. And remember, opposites attract. So in ionic bonds, which is when electrons are completely transferred or given and taken from one atom to another, this is going to be creating a positive and negative ion that are then attracted to each other. So let's take a look at the sodium atom here in the bottom left. In the sodium atom, there's one valence electron in its outermost energy level. And in the chlorine atom, there are 7 valence electrons in its outermost energy level. So, sodium needs to get rid of that one valence electron, therefore leaving its second energy level with 8 electrons in there to be its outermost and fulfilling the octet rule. And the chlorine atom is going to be receiving that 1 electron, therefore its third energy level will have 8 electrons and be also following the octet rule. So let's say they do that. Then now we get on our right the sodium ion and the chloride ion. And the sodium ion is positively charged and the chloride ion is negatively charged. So when they come together, they'll create sodium chloride, NaCl. So what are some of the properties of ionic compounds? Well, when they're formed, when electrons are transferred from a metal to a nonmetal. Again, they are formed when electrons are transferred from a metal atom to a nonmetal atom. A solid phase at room temperature. They have high melting and boiling points. They can conduct electricity if dissolved in solution, and they're very hard and brittle as well. Now, in metals, the valence electrons are delocalized, which just means that they don't stay with just one atom. All right, so they're going to be transferred back and forth in these metallic bonds. So they'll move between the nuclei of the metal atoms, and the protons are attracted to them as well. Now, metallic compounds are formed when the nuclei of metal atoms are attracted to the delocalized sea of electrons between them. Since electrons move so freely, metals are very good electricity conductors. And most are solid phase at room temperature. Metals are shiny, they're malleable, which means we can hammer them into flat sheets, and ductile, which means we can draw them out into thin wires. They're very flexible. So why do atoms bond? To become more stable. They want to reach that lower energy state. Remember, everything in our universe just wants to be lower in energy. We never see signs of warnings of rocks rolling back up the hill, do we? No, they want to fall down. And to get stable, atoms must have at least 8 outer or valence electrons. Again, 2 if they only have 1 energy level. Atoms will gain, lose, or share electrons in order to accomplish this. And again, that's called the octet rule. So, bond strength depends on the amount of energy it has. So the amount of energy required to break the bond is how we figure out the bond strength. So it doesn't take a lot of energy to break the weak bonds between a post-it note and the wall. That's pretty easily done. But it does take a lot of energy to break the strong carbon-to-carbon bonds found in diamonds. So in very general terms here, covalent bonds are the weakest. Covalent bonds are formed between 2 non-metal atoms. Ionic bonds are stronger between a metal and a non-metal, and metallic bonds are even stronger than that. And you can find many exceptions to this statement as well. Alright, so if you have any more questions, talk to me in class.